Have you ever been there? You're building a brand new feature, maybe for an e-commerce site. The shopping cart is working great, credit cards are processing perfectly. Then your boss comes by. Hey, can we add PayPal? Sure, no problem. A little if-else and you're done. Then it's, what about Bitcoin? Another else if. Then Apple Pay, Google Pay, Venmo, and before you know it, that simple, elegant function is a 200-line monster that's fragile, impossible to test, and actually costing the business money. Well, today, we're going to talk about the cure for that exact nightmare. It's called the strategy pattern.
So here's our game plan. We're going to start by really digging into that payment nightmare. Then, we'll see exactly why that easy solution is so bad by looking at the core software principles it breaks. After that, we'll introduce our hero, the strategy pattern, and walk through the code line by line. And stick around for the best part, seeing the incredible business turnaround this one change created. And finally, where else you can find this pattern out in the wild. All right, let's set the stage. You're on a new project, a shiny new e-commerce site. The first big feature is payments. And the first request is simple, right? Just let people pay with a credit card. You build it, it works beautifully, and everyone's happy. But, as we all know, it never ever stays that simple for long. And that's when it starts, that little trickle of requests that soon becomes a flood. The business sees all these new ways to get paid, and every single one becomes a new ticket in your backlog. What started as one clear task, well, it starts to get messy. And how do most of us handle that mess at first? We do this, don't we? A big, ugly, but hey, it works, block of if-else statements. You know, if the payment method is credit card, do this logic. Else if it's PayPal, do this completely different logic. Else if it's Bitcoin, do whatever that requires. And for a little while, it feels okay. But this solution is a ticking time bomb, and it leads to some very, very real business pain. And here is that pain in black and white. That simple code block balloons to over 50 conditional statements. Adding a new payment method becomes a 2-week-long ordeal of coding, testing, and just praying you didn't accidentally break something else. The risk is so high that you're slow to move into new markets, losing out on a potential 35% revenue growth. You can't even A/B test which payment options convert best. This isn't just about messy code anymore. This is a direct threat to the business's success. So, why does this happen? Why does the easy way turn out to be so hard in the long run? Well, it's because this approach completely tramples on some of the most fundamental principles of good software design. And these aren't just suggestions. They're the rules that keep our software from collapsing under its own weight. First up, we have the open/closed principle. It's a bit of a mouthful, but the idea is simple. Our code should be open for extension, meaning we can always add new functionality to it, but it should be closed for modification. We shouldn't have to change existing working code just to add something new. And as you can probably guess, our if-else nightmare fails this test spectacularly. Just think about it. Every single time the business wants a new payment option, what do we have to do? We have to crack open that shopping cart class and change the pay method. We are constantly modifying it. That completely violates closed for modification. And because we're always doing this risky surgery on a core piece of our system, we aren't truly open for extension either. Adding support for Bitcoin puts our perfectly stable credit card logic at risk every single time. And it doesn't stop there. We're also violating the single responsibility principle. A class should really only have one reason to change. But look at our shopping cart. It's supposed to manage items and calculate totals, right? But now it's also a credit card processor, a PayPal expert, and a Bitcoin wallet. It's doing way too many jobs, which makes it complicated, fragile, and a total nightmare to test. Okay, enough doom and gloom. We've established the problem. The code is a mess, it's brittle, and it's actively holding the business back. Now let's talk about the elegant solution that's going to fix all of this, the strategy pattern. The core idea here is incredibly simple but so powerful. We take a family of related algorithms, in our case, all the different ways to pay, and we wrap each one up in its own little self-contained class. We encapsulate them. This makes them completely interchangeable, like Lego bricks. The shopping cart will know that it needs to process a payment, but it won't have a clue how that payment is actually being processed. This is my favorite part. Theory is great, but let's see where the rubber meets the road. Let's walk through the code step by step and transform that brittle if-else disaster into a flexible, maintainable, and dare I say, beautiful system. First things first, before we write any logic, we define a contract. In this case, it's an interface we'll call payment. Think of it like a handshake agreement. It's super simple. It just says that any class that wants to be considered a payment method in our system must, no exceptions, have a pay method. That's the deal. So now we build our concrete strategies. We make a credit card class that implements our payment contract. It has its own data, card number, CVV, and its own logic. Then we make a totally separate PayPal class. It also implements payment, but it needs different data, like an email and password. So you might be asking, wait, they have totally different data and different logic. How does this work? And that's the absolute beauty of it. Internally, they are completely different, but to the outside world, they present the same simple face. They both honor the contract. And now, here's the real magic. Look at our new shopping cart. Its pay method is so much simpler. It just accepts any object that follows our payment contract. So the cart doesn't know, and more importantly, it doesn't care if it's getting a credit card object or a PayPal object. It just knows it can safely call the .pay method on whatever it receives. That ability for an object to take many forms is called polymorphism, and it is the key that makes this whole pattern work. All right, this is the moment where it all clicks. The business inevitably comes back and says we need Apple Pay. Before, on the left, we have to go back into the shopping cart, add another else if statement, and retest everything, hoping we didn't break something. But now, on the right, we just create a new Apple Pay class. That's it. We don't touch the shopping cart, we don't touch the existing payment classes, we just add a new, isolated piece of functionality. That is the open-close principle in its purest form. So, we've cleaned up our code. We developers can sleep better at night. That's great for us. But what does this actually mean for the business? Well, the impact wasn't just small, it was a complete turnaround. We took our biggest piece of technical debt and turned it into a massive competitive advantage.
I mean, just look at this number. 12 times faster. What used to be a painful 2-week-long project was now being done in just 2 hours. Think about that agility. That's a 12-fold increase in the team's speed. And that speed translated directly into cash. Because we could add more payment options so quickly, we could give customers more of what they wanted. The result? Checkout conversion rates jumped by 22%. That's not just a vanity metric. That's real revenue. And this new agility literally opened up the world to us. Adding specific regional payment methods for international markets used to be a non-starter. Now we could do it in a matter of hours, unlocking new markets and boosting international revenue by 35%. When you put it all together on one chart, the story is undeniable. A 1,200% increase in development speed, a 22% lift in sales conversions, and a 35% boost in international revenue. These are game-changing business results, and they all came from making one smart architectural decision. Now, the strategy pattern is definitely not just for payments. It's far from a one-trick pony. In fact, once you understand this core concept of wrapping up interchangeable algorithms, I promise you, you'll start seeing opportunities to use it absolutely everywhere. Let's look at a few other examples. Think about a program that needs to compress aisles. You could have a zip strategy, a guy zip strategy, a RAR strategy, and the program can just pick the one it needs at runtime. Or how about sorting data? You could swap between quick sort for speed or merge sort for stability. My favorite example is navigation. You're going from point A to point B, but the strategy for getting there is totally different if you're in a car, on a bike, or walking. It's the same pattern. So let's just put it all together in one final side-by-side comparison. The difference is just, it's night and day, right? We went from a 2-week high-risk process to a 2-hour zero-risk one. We went from having to retest the entire system to just testing one small independent class. We went from a single bug taking down everything to bugs being neatly isolated. The choice is pretty clear. And I'll leave you with this question. Think about the code you're working on right now. Where is that messy chain of if-else statements? Where is that big switch statement that's just waiting to be refactored into a clean, flexible, and powerful strategy pattern? Go find it. Your future self and probably your company's bottom line will thank you for it.